Hello, I'm Neil Ebenezer, the current team leader of the High Volume Transport Applied Research Program, or HVT. The program was launched in 2018 and is a 7-year, £18 million investment from the UK Foreign, Commonwealth and Development Office, or FCDO. And this is to undertake research into the complex and interrelated issues of sustainable transport development across sub-Saharan Africa and South Asia. I would like to thank the colleagues at UKCRIC today for giving me the opportunity to speak. This is part of the UKCRIC's webinar series on systems challenges in developing climate-resilient infrastructure in Africa through the lens of transport. I would like to take the opportunity today to be one of the first presenters of a new initiative to develop an Africa CRIC, a collaboratorium for research on infrastructure and cities in Africa. But more on this later. So I will briefly outline the challenges and opportunities that infrastructure development is facing in Africa and tell you a little bit about the research commissioned by HVT and the impact that we're having in various countries. So we know that Africa has huge potential, and it is the youngest and fastest growing population on any continent. It has vast natural resources and can play a crucial role in securing food, water, and energy security. African cities are growing fast, with urban populations in Africa set to increase by 950 million people, and over 65% of the continent's population is expected to live in urban areas by 2060, by which time there'll be over 1 billion people across Africa. So the increased population and increased urbanization poses at the same time both opportunities but significant challenges, especially in infrastructure and what that needs to be built in a climate resilient way. Some of the challenges that Africa faces are really around infrastructure as well. So we know that there's inadequate infrastructure, insufficient physical infrastructure such as transport, communication, water, and power. And these remain a significant obstacle to Africa's economic growth. These deficiencies hinder economic activity, efficiency, and competitiveness on a global market. It reduces access to markets. A poor infrastructure restricts access to African markets as well as global markets, and especially in interior regions of Africa where the infrastructure is generally quite poor. Without robust infrastructure, Africa cannot achieve the expected growth levels that it has the potential to do. Infrastructure development is intrinsically linked to Africa's economic growth. Large commodity finds, for instance, in oil, gas, minerals, drive the need for this improved infrastructure. But developing infrastructure that meets future needs is costly and complex. So how should Africa respond to growing issues of climate change and digitalization while exploring the opportunities to meet growing challenges? Despite accounting for around 12% of the world's population, Africa currently generates only around 1% of global GDP and 2% of world trade. We know that developing infrastructure that addresses the needs for whole population where we live is complex, but the demands for these limited resources are growing increasingly as we continue to try to achieve the infrastructure that's needed. At the heart of this is finance. It's available, but accessing it can be difficult. And sometimes the unforeseen consequence of actions can lead to increased indebtedness for many African countries. So we know that governments across Africa are making enormous investments to build and maintain infrastructure. These efforts are supported by funding and financing from multilateral development banks, private finance, and other sources. For example, we know that the multilateral development banks loan about $20 billion a year on transport infrastructure alone. But that is not, that figure of 20 billion does not include the transport infrastructure that is funded by governments in Africa as well. So the community and private sector are also investing. However, even when you put all of these finance modules together, this is still insufficient to meet the challenges that Africa currently faces. So, despite the pressure to make good decisions, there's often a lack of applicable evidence to inform important investments and planning. The evidence base is often out of date and inadequate. And this is really where HVT comes in. HVT is trying to provide a new body of research to help better inform the decisions of policymakers and planners and to make road and rail transport greener, safer, more accessible, affordable, and most importantly, inclusive. And to ultimately allow the policymakers and decision makers to make good investment decisions that will help drive the economic development and reduce poverty for their populations. So we know that having robust evidence is absolutely critical when decisions need to be made. Without it, decisions are less informed or even uninformed and can lead to general misinformation and costly mistakes. The research from HVT aims to power change in three ways. We create an understanding for decision makers and practitioners of the issues and challenges to create sustainable and resilient transport. We build knowledge, skills, and attitudes for researchers, policymakers, and others involved in our work. Our research leads directly and indirectly to instrumental changes in policy, program, and transport practices. The focus areas that we have are really on inclusion, climate change, crisis response, access and infrastructure, policy and planning. And within those, we are covering areas of data and digitalization, climate mitigation and adaptation, and road safety as well. Today, I'd like to give you a flavor of some of the research that we've gathered as a way of introducing you to the work that HVT has done in the past. And in order to do this, rather than me speak about it, I thought it would be best if we could hear from those researchers who've actually done the research. So I would like to explore some of those areas today with you, because if we're trying to build climate resilient transport infrastructure, we need to focus on a number of key areas. For instance, data and the integration of the data is absolutely key. I'll refer to a climate resilient tool that can map the impacts of weather, as well as providing updates to how you can build roads and pavements. So the first presentation is from Justin Kutsia, the CEO of Go Metro. And this company led the Africa Urban Mobility Observatory, OMO. And this research project aims to promote inclusive, low-carbon mobility in African cities by piloting big data applications to generate data, benchmark performance, and draw policy insights in 6 African cities. Justin will highlight some of the innovative ways that data can be collected. And we'll hear now from Justin and the Go Metro team.
Great. Good morning, everyone. Thank you so much for having me, HVT and Neil. Thank you, moderator. And it was very nice this morning to actually be able to talk about this project, which we've recently concluded, and just reflect on some of the learnings. So I'll be talking for the next 20 minutes about the African Urban Mobility Observatory and some of the work we did over a course of about 2.5, 3 years to firstly establish data collection methodologies that can work in African cities, to look at baselining data collection, meaning paper and a clipboard, which would be the traditional way, and then looking at new technologies like WhatsApp surveys, USSD surveys, and using mobile apps to collect people's movement data so that we can build up a picture for mobility indicators. So with that introduction, I'm going to try and go forward. Yes. So we were funded by the HVT program through FCDO and UKAID, as mentioned, and we partnered with UN Habitat, Wuppertal, and UEMI in order for us to be a consortium that can address multiple areas in Africa. There was a certain Gail Jennings on the team, as long with Heather Allen as well. So we also looked at ways of collecting data that would allow us to collect gender-specific questions and gender-specific information, and looking at the difference in collection approach. So the research questions we had were, well, how do you collect information on modal share? What's the role of data in modal share information in particular? If we look at ridership in transit ridership, cycling, non-motorized transport, can we use the data to find the policies that work? Because if you have a high percentage of cycling or a high percentage of walking, you're either doing something right or something accidentally right. And what is that? And often, we know the modal share, but to try and find the causality is something we were searching for. And then we also looked at the informal transit sector. You could call it the invisible sector. Everyone generally accesses the data around that mode at counts, but not really knowing what's happening within that network. So we also looked at ways with which we can collect data in that regard. I'm going to move a bit faster now. So what we tried to do is look at would it be possible using different data collection techniques to measure 19 mobility indicators in 6 disaggregation categories. So the indicators are the mode you're on, the travel time, the period of travel, why you're traveling, and the disaggregation would be your gender, or the number of transfers you do, or what your purpose for the trip was. And so we were aiming to collect lots of trip data and slice and dice it according to these vectors. Well, the power of a mobile phone and the power of a user is that we can get the location just by the GPS. We can also, with the user's cooperation, collect their movement data. Over time, we can ask them, well, you went into that neighborhood. What were you doing there? Was it shopping, work, education, leisure, social, family? You can get infer the trip purpose through the relationship and slowly but surely build up a view of that person's travels. And by doing this thousands and thousands of times, thousands of people's travels. So that's the theory. That's what we'd like to achieve. Now let's show you how practically difficult this is. And it really is difficult. This technology has great appeal. We're on, with this project, I think we're on the bleeding edge, not the leading edge. But let's show you the lessons we've learned along the way. So we were able to build technologies that were able to track people's movement patterns. So we could track people's movements through the day with their permission, with their knowledge, with their agreement, and with their support. Totally GDPR compliant and POPI compliant in South Africa, because the person could see what we were collecting and had the right to delete it. The web-based visualization portal allows you to navigate, so you can see there's the first 6 pins, but of course we'd like to add more and more cities. And so online you can navigate and you can click and explore these cities, download data sets, download reports, download papers. We've been trying to collate all the master plans we can get our hands on so that we can also add the master plans to the city. So that when you're a researcher, you can visit this portal as one of the destinations to visit, and hopefully you've got maybe not up-to-date reports and up-to-date data, but at least it's a starting point for you to have some. And so, so just to sum up, these are African-suited technologies, USSD, hopefully WhatsApp if we can crack this right. And there's a benchmark against going out with a clipboard. We won't replace going out with a clipboard, but the question is, who will we go and ask these questions? My sense is that we'll keep going to, let's say, the elderly or the non-digitally okay, for us to make sure that their voices are heard, and then those digital citizens will be able to reach at a broad scale. We've got the data visualization starting, but now it's really up to you. It's up to you to engage as researchers, to say, hey, let's get our city on OMU. It's open source, it's Creative Commons. It's really available for us to add cities, add data sets, add reports. And if you want to experiment with this technology, if you want to launch this type of survey in your city, again, please talk to us. We can help you not spend that £15 per user, but make it £1 per user, and thus make things work. Here's just the breakdown of all the costs. So you can see the campaign costs that we ran, the setup costs and survey types, and the target unit costs. So what you see here is USSD always beats field survey, whereas a field survey would cost £4 per response to £7 per response. USSD and WhatsApp, but with some caveats, comes out to £1 per response. So what does it mean for us to take the same collection budget and get 4 times the responses? That's big data. Now we're talking about big data. So we'd like to thank UKAID, FCDO, HVT, all of the program sponsors and program managers that made this possible. UN Habitat, Wuppertal, and UMEI, who are partners, Gail Jennings and Heather Allen as well. We've really, I think, built a base and shown what's possible, what's feasible, but it's really about it being a living observatory. And so we'd like to partner with researchers and cities to make sure that this continues to measure and grow as our cities continue to measure and grow. Thank you.
So we've heard about from Justin, and we've heard about how we can actually look at some of the innovative ways that data can be collected that can better inform decisions for transport planners and other key decision makers. We know that transport is a major contributor to climate change and is responsible for 24% of greenhouse gas emissions. Emissions from transport have continued to increase annually and have grown faster than those from any other sector. Although Africa has historically not been a major contributor to greenhouse gas emissions, the rapid urbanization that we've discussed earlier and that change is putting pressure on infrastructure to change fast and potentially add to the climate crisis. So the development of climate resilient transport is crucial. And so our next presentation comes from Dr. Simon Blaney, who is professor of sustainable transport and the head of the University of Southampton's Transportation Research Group. He led the HVT project on decision support systems for resilient strategic transport networks in low-income countries. The tool offers innovative and free-to-access ways to use the latest data to create climate-resilient transport. Simon's presentation will provide an overview of the research findings underpinning the decision support tool, which has been developed during the project. And this system is built around an interactive web platform and aims to support investment decisions and option selection for long-distance strategic land transport networks exposed to climate risks. So over to Simon.
Good morning, everyone. My name's Simon Blaney. I'm Professor of Sustainable Transport at the University of Southampton in the UK, and I'm going to give you a brief overview of our project on decision support systems for resilient strategic transport networks in lower income countries. I'm sorry I can't be with you in person due to teaching commitments, but I hope this recorded overview will give you a flavour of what we did in the project. The aim of the project was to provide transport decision makers in lower income countries with support tools that would enable them to prioritise interventions in transport systems that would help to deliver more sustainable and more resilient long distance transport networks. It was a 2.5-year project running from 2020 through to early 2023, focused on 4 countries in Africa: Kenya, Tanzania, Uganda and Zambia. However, we very much aim to develop transferable methodologies which could be used elsewhere as well. The first stage in the project involved the development of a set of future scenarios for various key drivers of transport demand, such as population and the economy, for the period through to 2050. Alongside this, we developed a list of potential interventions in transport that we wanted to examine, alongside a data collection exercise on transport infrastructure and usage within our case study region. The scenario development and data collection exercise underpinned 2 substantive areas of analysis which formed the bulk of the research project. The first of these was a transport risk and adaptation analysis which focused particularly on flooding. This was because flooding is already a significant problem in the region and is likely to get worse as a result of climate change. Flooding does result in significant socio-economic losses associated with transport network disruption, so we need evidence of the impacts of current and expected future hazards. We developed a methodology for systematically assessing where transport networks are exposed to extreme natural hazards, identifying what the direct physical damage is likely to be to the assets exposed to these hazards, assessing what the direct and indirect economic losses associated with infrastructure failures are likely to be over a long time period, and identifying which climate resilience adaptation options should be prioritised in which locations. A range of output metrics are produced by this methodology, as you can see here, and while in this case we focused on flooding, the methodology can be transferred fairly easily to examine other hazard types. Of course, resilience is just one of the factors that need to be considered when prioritising interventions in transport systems, and so in parallel to the resilience analysis, we developed and populated a comprehensive set of sustainability indicators which can help assess the overall impacts of a transport scheme. These indicators then form the basis of our Transport Intervention Option Assessment tool, which is intended to assist decision makers in identifying the overall sustainability of different transport intervention options. It adopts a multi-criteria analysis-based approach, which gives a high-level indication of how any given intervention is likely to perform with regard to different aspects of sustainability, and it can incorporate outputs from locally used modelling tools where they exist. The final stage of the project involved integrating the resilience analysis tool with the sustainability assessment tool in our online SRAT systematic risk assessment tool for road and rail transport infrastructure in East Africa. This online tool allows decision makers to examine the effects of flooding on different elements of transport network, to view the potential economic impacts of flood-related disruption to individual network links, to review the costs and benefits of different adaptation options, to consider the impact of a given intervention on a range of different sustainability indicators, and finally to review the overall impact of the scheme on the sustainability of the transport network in the region. In order to maximize the accessibility and usability of the tool, all the code is open source and the assessment is wherever possible based on open source datasets. If you'd like to find out more, you can try out the tool yourself by visiting this web link, or do email me if you'd like to discuss any aspect of this presentation further.
Simon's research shows that data and evidence can be available to inform decisions, but some of the questions still remain about how countries should use this data, how they truly understand if their decisions and plans are developing greener transport or not. And these are some of the ways that it's not just about using the tool, but it's about making the tools that are available work in country for the specific challenges that any one country might face. Our next presentation is from Andrew Otter. He's from the Transport Research Laboratories, TRL, and they have developed the new version of RoadNote 31 on building climate resilient road infrastructure. And just for some background, RoadNote 31 was first published in 1962, revised in 1966, and in 1977 and 1993 to take account of advances in our understanding of the behavior of road building materials and their interaction in pavement and pavement design. Many of these advances have been made by engineers and scientists working in tropical and subtropical and temperate climates. But a considerable amount of both fundamental and applied research has been necessary to adapt and develop the knowledge so they can be used with confidence in tropical and subtropical regions, especially when we're looking at mitigating some of the impacts of climate change and increasingly rise in temperatures that we're seeing across the world, most especially felt in some of the poorer countries, especially in Africa. In addition to differences associated with climate and types of materials, problems occasionally arise in some countries from uncontrolled vehicle loading, unreliable road maintenance. At the same time, the level of technology and budget available for construction and maintenance can be relatively low. All these have presented a unique challenge to the highway engineer. So in this edition, which HVT has funded, RoadNote has drawn on the experience of TRL in collaborating with experts and organizations in various parts of the world, and rigid pavement design has been included in this new edition due to the importance of rigid pavement in combating climate change. So over to Andrew to tell us a little bit more about the work that TRL did on developing RoadNote 31.
Hello, and thank you for this opportunity. I'm here to present to you about an important document in road provision, and that document is RoadNote 31, a guide to the structural design of surface roads in tropical and subtropical regions, and this time integrating climate resilience into road networks. My name is Andrew Otto, and I'm the team leader for updating of Road Note 31. Now let us look at some of the current and future challenges that the world is facing as a result of climate change. We are seeing an increase in damage to coastal infrastructure as a result of sea level rise. We are seeing frequent damage to access infrastructures that link communities to important services. We're also seeing an increase in damage to road pavements as a result of frequent heat waves. Other challenges include environmental degradation as a result of increased direct emissions from various forms of carbon generating entities into the atmosphere, increase in particulates from tire degradation on roads, increase in oils and fluids used by vehicles leaching into nearby fields and so on, and contamination of streams and rivers. And yet these are some of the sources of potable water for communities. We are also seeing an increase in waste from expansion of communities and expansion of infrastructure. Now let us look at how the RN31 5th edition addresses some of these challenges that we've looked at. And the update to the Road Note 31 now includes guidance on the use and design of rigid concrete pavements, particularly to address the frequent failures that are observed as a result of climate change. And likewise, because of damage to infrastructure that is increasing, RN31 now incorporates pavement rehabilitation to address these challenges. We also have got climate resilient surfacings to enable the infrastructure withstand the effects of climate change better. We have also included the enhancement of pavement drainage so as to be able to withstand again some of these climate change effects. Likewise, to make all of this possible, we have enhanced the traffic, subgrade, and materials chapters. Particularly in the materials chapters, we now have the use of recycled materials so that we at least address the challenge that is growing through the production of a lot of waste products as a result of expansion of communities and expansion of infrastructure. To address the challenges of increased temperatures and heavier traffic loading that would cause severe or premature rutting of pavements, we have incorporated several methods of undertaking rut-resistant design of asphalt surfacings. We have also incorporated the use of epoxy-modified materials to address two challenges, one of increased precipitation that would otherwise cause severe damage to pavement surfacings, and the other to address oxidation that would occur as a result of the extreme temperatures, as well as rutting that would also occur as a result of extreme temperatures. Epoxy modified materials have proven to be successful several years ago, but their use was limited, and we are now bringing this to the forefront. We've also linked the durability of asphalt surfacings by referencing to a document called Road Note 42, which is available at the TRL website. We've also included methods of adapting pavements to changing subsurface moisture conditions caused by an increase in overall rainfall, and also methods of adapting pavements to extreme flood events. We've also included methods of adjustments for drainage structure dimensions to cater for increased water flow as a result of climate change, and to cater for secondary effects such as the increase in siltation of drainage structures. We've also catered for methods of arresting debris and particulates that come as a result of the use of the road infrastructure through provision of sustainable drainage systems that we have now incorporated in RN31. We've also included the carbon footprints of various pavement materials so that designers and planners take into account the footprints of various materials in the provision of road infrastructure. You can download the RN31 5th edition from the following websites listed here, and you can also find further information on this at transportlinks.com. Thank you all for listening, and I hope that you have a successful conference.
So thanks to Andrew for those insights on that. And I think for those interested in developing and building new roads, RoadNet 31 will be an invaluable resource. Finally, I'd like to share the last segment of these presentations is on a project from the Stockholm Environment Institute at the University of York. And this has been looking at inclusive climate resilient transport planning in Africa. And they've been developing a guide for planners that provides practical tools for ensuring all voices are heard in the planning process for climate resilient transport, especially associated with active mobility. And so we have this short clip that sort of surmises in quite a short a little video the work that's been done and the considerations that need to be considered when looking at transport planning in Africa. So I'm pleased today that I've had the opportunity to share some of the research coming out of HVT and contributing to the evidence of how best to build resilient, inclusive transport that values how people live and work. I would encourage you to explore our full program of research, which is accessible on our website. What you have heard today is just a small subset of a vast body of research. HVT has been running, as I said, for 6 years. It is now in its final year, looking to disseminate its activities, which is one of the reasons why we're doing this this presentation here today, is to encourage people to use this body of work that's been created and to take that and apply it in the various areas that they might be working in, but also to build on the research and to take and increase our knowledge in the various areas that HVT has funded research. So I'd like to thank you for your attention, and the next segment will be on the development of the Africa CRIC. Thank you. What I would like to talk to you in the remaining minutes is really the development of an Africa CRIC, which I mentioned. I think when we're looking at some of the challenges faced for Africa, we've got increasingly issues around climate change, in addition to things like the El Nino effect, especially in Southern Africa, where you have twin impacts of drought and flooding. And so how do you develop resilient infrastructure to deal with these future challenges and changes that we see coming forward? And we need to have a just transition in needing to tackle issues to ensure that all countries in Africa can develop to better meet the needs of its people. Too often we're seeing technologies and approaches from the global north being transferred to the global south and not failing to make that impact. And so there's a strong need to reconsider focus on key challenges, but not to do this in isolation. We can't look at just transport, for instance. And I think what the Africa CRIC is trying to do is to create a shift to consider key infrastructure challenges in a more holistic approach, using the concept of complexity science or systems of systems approach to better address the challenges that the continent faces. These are ultimately some of what the Africa CRIC seeks to develop a body of work from multidisciplinary researchers and academics who can understand and contribute to dealing with this complexity and to become part of a movement of change. I don't think it's long sufficient to just consider transport or energy or any other system on its own, but to consider what this might mean in relation to other infrastructure challenges they face and whether these can be worked in cohorts to make sure that people will have the use of the infrastructure that better meets their needs. So it needs to be inclusive, sustainable, and to be able to adapt to the needs of people and to the climate for the future. It is quite a challenge, and UKCRIC have kindly indicated support for the development of an Africa CRIC that can help to contribute to debate on future infrastructure needs for Africa. This needs to be built on excellence in academia that can help to develop a rigorous, evidence-based system across multiple infrastructure sectors and for a more integrated approach to be adopted. I would like to end the call with an action to contribute to the development of an Africa CRIC and work towards tackling the issues of complexity that have been outlined. If interested in becoming involved in this initiative, please get in touch with the UK Secretariat or with me to find out more about it and to find out how you can be involved. Thank you.
Wonderful.
Not sure if there's
Thank
any
you very
questions.
much. Very much. Thanks very much, Neil. I'm just going to stop the share so that we can see each other, and I need to just stop the presentation so that I can see you all. Okay, there we go. So yes, so yes, at this point, we'd like to just invite the attendees to ask any questions that they may have for Neil. And perhaps just while people are thinking about the questions, if maybe I could just ask one to start with, if that was be okay. And my question is around, I have two actually. So maybe I'll start with the first one, which is hopefully a straightforward one, and then we'll open it up to people who've thought of questions, and then I'll come back to my second one. And my first question is, what are the next steps for HVT for that program of work?
So currently HVT is in its final year. So as we said at the start, it was initially a 5-year program that was extended for a further 2. We now have, I think, an excellent body of research. I know we had difficulty sharing that today, but if people go onto the website, they will see reports from the work that has been done across different areas. Today, I focus mainly on infrastructure and those that support it. There's also excellent work that has been done on inclusion, disability, access, as well as road safety. So there's a body of work, I think, that comes through from HVT that has been very good. We're in the final year. We're looking to promote that research which has already been done. There are 6 further projects that are currently running. There are 2 in Asia that look at aspects of electromobility, one looking at gender issues of choice decisions in electromobility in India, but also looking at low emission zones in historic cities, and they've chosen Namibia in one of the other projects. But the 2 flagship projects that I would highlight would be the development of a transport decarbonization index, and this is run by a consortium LOCAT, and the other is looking at improving access to climate finance, which is done by the World Resources Institute. And then lastly, to say that the work from Stockholm Institute, University of York, that has been taken forward to expand its role. And there was the development of the tool, the SheCan tool, which is looking at sexual harassment on transport. And that was done as a pilot in Nigeria. It's now being rolled out to 10 other countries across Africa. So that's the work that will take HVT forward to the end of its program. The FCDO are looking at development of an infrastructure project to take on from where HVT has left off, but that's still in development.
Thanks very much, Neil. So now to any questions from any of the attendees. Oh, I've got a hand raised. Yeah, so go ahead and ask your question. Thank you.
Thank you. Thank you, John. Thank you, Neil, for the great presentation. Just two related questions about data related. So what was the challenge in getting the various data sets you need for this sort of analysis? And you mentioned also you're planning to extend this in the Africa CRIC program, and applying this system of systems or complex approach. And what sort of issue you envisage, given the experience you have so far? This is generally a global South issue, not just particularly in Sub-Saharan Africa, but I would be interested to hear your thoughts on that. Thank you.
Thank you. So thank you very much for the question. So I think just to sort of bring some clarity into it. So initially, the presentation I gave you was of the work that HVT is doing, and one of them was on better data integration. So there was the Metro piece of work that was done in South Africa by a South African company working with the core on using data sets from multiple sources, including mobile phone data, and look at how they can better integrate it. So this was moving away from some of the old clipboard ways of collecting data or the counts that people would do. And so just trying to find different methods of data collection. Similarly, the project that has recently been done in Sierra Leone was looking at computer vision software to look at how that could complement the data collection that we do and make it a bit richer, less labor intensive. And so we could actually end up with better data sets. This could then be used in multiple ways, including feeding into software designs and use elsewhere. So I think that is more about an approach that is taken on the data and the integration of data. The issues around the compositions of complexity and the systems thinking is one that sits outside of HVT, but I was trying to show the link that where we are purely in one system of transport, there are systems that are adjacent to that or integrate into it. So for instance, we talk about electromobility. How can we not consider an energy system in this transition? And so, we need to look at the infrastructure to develop in a more holistic way. And the best way to do that is to look at this in a more integrated way. And that is a leads to some complexity. And there's a whole science behind this, which I'm sure you're more familiar with than I am, perhaps. But also, I, in my simplistic mind, would sort of look at it, that integration of different systems. There are some areas of common ground, but there are also ways we need to look at interdependencies, but also some of the challenges are unforeseen consequences of actions. And for many years, Africa, across Africa, as you rightly say, but I've seen it especially in sub-Saharan Africa, has been at the vagaries of the interplay between those systems. So we try to get a transport system, it doesn't take account of water, it doesn't take account of energy, and so one suffers while we try to improve the other. And yet for the people, they need all of that to come together. So the concept of the UKCRIC is really to create a group of we'll start with academics, but other researchers, other actors can come into this. It is not going to be something that's restrictive, but we thought as a small kernel to grow something. It's a change, I would think, in some of our approach taking. There are other organizations trying to think along similar lines, and where possible, we will work with them to do that. But obviously, the focus for UKCRIC has been infrastructure. Infrastructure, I think I've shown in this presentation, is absolutely key to development in Africa. I focused on transport, but this could be rolled out across the board. So I think we're looking for people like yourself, possibly, to come on board and say, well, if we're looking at some of these challenges, what do we bring to the table? How can this work? And at the moment, it's concept stage of trying to build something. So please feel free to come on board.
Thank you very much for that. Cheers.
Thank you.
Thank you. And we've just got 3 more minutes. Does anyone have any questions that they'd like to ask? Yes. Azana, please ask your question.
Thank you very much, Joanne, for inviting me, and thank you very much for this presentation. I would like to ask, in terms of, high volume transport, particularly on freight, what research gap, do you think there is that need to be filled or that need to be given priority in sub-Saharan Africa? Thank you.
Thanks. I mean, so the HVT program has done some work on freight, focused a lot on generally on emission and how that can be reduced. We've looked at different, for instance, we have funded a project looking at different drivetrains for trains. So, the focus has very much been on electrification, battery, but we actually looked at a project. There was work coming out of Birmingham University in the UK, looking at the Hydroflex train and whether that could work in other contexts. And HVT funded a research program to look at just that, so hydrogen train. But I think when we're looking at some of the issues across Africa, we would look at the road system, because currently that's still the major way that freight is delivered. But it's also looking at some of the integration. So you can actually start looking at software where we actually get, say, trucking, for instance, to not run empty, so that you can use a system of where different delivery companies are working together. But how would you actually look at integrating some of that? So this is where, when you're looking at this concept of the UKCRIC, if I take that as the example, We can focus on the transport side. We can focus on the energy side in terms of the drivetrain, the fuel that's being used, and so forth. But we can also focus on a digital infrastructure that can allow, for instance, a FedEx or a DHL or whoever it might be, not to run their own vehicles, but actually to share a vehicle, because you can actually use concepts of blockchain or various other things to actually help integrate that, reduce the amount of trucks on the road, save on carbon emissions and greenhouse gases, but also reduce congestion. And at the moment on African roads, that's challenges. The other is obviously the road system that is then going to be fit for purpose when we look out to 2050, 2060. And that's why we funded a piece of work on Road Note 31, how to build climate resilient road and pavement.
Okay, thank you.
Thank you very much.
Great.
Thank you.
Wonderful.
Thank you very much.
Thank you for your questions. So we are out of time now, and I know some of us have other obligations starting at the top of the hour. So I want to just thank everyone very much for attending, for your questions, and we will I expect we will reach out to you actually about the Africa CRIC potential that has, as that gains momentum as we go forward. It's in its early stages of thinking around what that might mean, but we think it's a compelling idea, I think. So do look out for communications from us from that. So I think that's it. Unless anyone else has got anything else, we will go ahead and close the webinar. Okay, thank you very much, and thank you, Neil, very much for joining us.
And apologies.
No, for putting out, they're inevitable, the technical difficulties, aren't they? And it just shows, it wants to how good technology is, but also we need to allow a bit more time and space for it, don't we?
Yeah, sure. Okay, thanks everyone. Take care.
Thank you very much. Bye-bye.